Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Surviving the Younger Dryas. Today, we are in the middle of a global pandemic caused by the COVID-19 coronavirus, and we can appreciate better the hardships that our ancestors endured at the onset of the Younger Dryas. Our modern society has developed a network of farming, transportation, and communication that allows us to just go to the store and buy what we need. But not right now. The spread of the highly contagious virus has disrupted the precarious equilibrium of our society. The stores have empty shelves as people panic and stock up to survive until the danger of the epidemic passes. Supply chains are disrupted because traffic is halted to control the spread of the virus. And our fears grow because we do not know if we will die from the virus, or if we survive, how long it will take for life to return to normal. The stock market is plummeting because investors have lost confidence in the growth and stability of our economy. Retirement savings are losing value and creating uncertainty about how to meet future needs. Governments are trying to slow the rate of virus infection by restricting travel and person-to-person contact. International and local borders are closing as quarantines are enforced, and people are losing their jobs because the service industries are forced to shut down. With this frightening frame of mind, let us go back 12,900 years to the time when a 2-kilometer wide comet fragment hit the Laurentide ice sheet in North America at a speed of about 60 kilometers per second. The projectile was about the size of the Brooklyn Bridge, but it was coming really fast and had great kinetic energy. The passage of the comet fragment ignited forest fires, and the impact on the ice sheet sent chunks of glacier ice in suborbital ballistic trajectories. Catastrophes of such magnitude seem to develop in slow motion. It took 30 seconds for the extraterrestrial projectile to excavate a 44-kilometer crater in the ice sheet. The explosion of the impact vaporized the projectile and produced steam at high pressure that accelerated the ice pieces of the ejecta curtain to speeds of 3 to 4 kilometers per second at angles of approximately 35 degrees. The blast of the impact was fatal to any fauna within 500 kilometers from the impact point. Seismic shock waves were transmitted through the ground at speeds of 5 to 8 kilometers per second and were felt within 5 minutes in the Rocky Mountains and in the east coast of the United States. The sky turned ominously dark as the ejecta curtain expanded and blocked the light of the sun. The glacier ice chunks that formed the ejecta curtain started making landfall in the east coast from 6 to 9 minutes after the extraterrestrial impact. The initial impacts of the glacier ice shook and liquefied the ground close to the water table, so that the subsequent impacts that fell on the liquefied soil created conical penetration funnels that became shallow elliptical bays in the trembling ground. By 10 minutes after the extraterrestrial impact, the secondary ballistic sedimentation had taken its toll. All the megafauna and Clovis people that had inhabited the United States from the Rocky Mountains to the East Coast were dead from the horrific hailstorm. The clouds of steam generated by the impact on the ice sheet started to condense as dark storm clouds. Water carried above the atmosphere in the ejecta curtain turned into a fog of ice crystals in low Earth orbit that blocked the light of the sun. Thus began the days of darkness that enveloped Earth within a few days and marked the onset of a global winter. Soon the temperature plunged approximately 10 degrees Celsius and the Earth started a glacial period known as the Younger Dryas that lasted 1,300 years. The cold, dark, and snowy days of the Younger Dryas brought hardships for the animals and people that were outside the kill zone of the glacier ice bombardment. Traditional migration routes were disrupted and the vegetation on which the fauna had depended for nutrition and shelter was destroyed and unable to grow without sunlight. This affected the whole food chain and resulted in the extinction of many species, including mastodons, camels, mammoths, lions, giant armadillos, and saber-toothed tigers. Humans were also affected by the cold weather. Geneticists have found a bottleneck of Y chromosome diversity that started at the onset of the Younger Dryas. Human chromosome diversity started increasing only 7,000 years ago in the Near East and Caucasus region, which was located far from the impact point in America. The Younger Dryas cold event affected human genetic diversity for 5,900 years before it started to recover. That is 4.5 times the length of the cold event. The discovery of Göbekli Tepe has opened a window into a human culture that survived the Younger Dryas cataclysm and became the cradle of civilization. What can we learn from all this? Perhaps nothing, but we may be able to extrapolate and say that if the coronavirus creates a global crisis that lasts for 1 year, it may take 4 or 5 years for our lives to settle into a routine full of hugs and kisses like what we had before the virus. In the meantime, we need to wash our hands, keep our distance, and stay healthy to survive this epidemic. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.